A study is being conducted in which the health of two independent groups of 10 policyholders is being monitored over a 1-year period of time. Individual participants in the study drop out before the end of the study with probability 0.2, independently of the other participants. What is the probability that at least 9 participants complete the study in one of the two groups but not in both groups? So the first thing we're going to do, we're going to let random variable x1 represent number of participants completing the study in group 1. And similarly, the second random variable represent the number of participants, and I'm going to write quotes because it's the same text, in group 2. Okay, so now notice that we're talking about individual probability, we're talking about independence, okay, and we're talking about overall probability that depends on the number of participants. So we're talking about binomial distribution. So x1 and also x2 will have the same binomial distribution, okay, with two parameters. The parameters is the number of people, which is 10 in each group, right? 10 people, and the probability of completing is going to be 1 minus 0.2, right? Because the probability that they drop out is 0.2 for each person, right? So the probability that they do not drop out is the complement of that, which is 1 minus 0.2, so that's 0.8. So essentially what we're trying to find the probability that at least 9 participants complete the study in one of the two groups, but not in both groups. This can happen if we have the probability of the number of people in the first group will be greater than or equal to 9, combined with the probability that in the second group fewer than 9 people will complete the study. Okay, and now also we're going to add the second case. We're going to add the second case in which the number of people in the first group completing the study will be less than 9, right, together, and I'm multiplying, right, I'm multiplying because that will happen at the same time, and there's independence, right, and at the same time in second group there will be at least 9 people completing the study, right? So these two cases, when added together, they satisfy the condition that we have to have at least 9 participants completing the study in one of the two groups, but not in both groups. So obviously here this group will complete the study, at least 9 will, and in this group, in the second case, at least 9 will complete the study. And notice they're separate cases, that's why we're adding them. They can't happen at the same time. And we're not including the case when both groups have at least 9 participants completing the study, because the question says but not in both groups, right? So these are two cases that we need. Now let's try the first case. So the first case probability, since we're talking about binomial distribution for both, let's try to find this first. We're going to have so the probability function for the binomial distribution is going to be n, choose k, the probability to the kth power, and then the probability of not happening for a given event of not completing the study is to the power of n minus k, right? So keeping that in mind, we understand that k will be the 9 here, right? So here's what we're talking about. We're talking about the probability of x1 being equal to 9 plus the probability of x1 being equal to 10, right? So 9 plus the probability of x1 being equal to 10, and that has to be multiplied to this, right? But notice that this is a lot of cases, x2 being equal to 8, 7, 6, 5. We're not going to add all that. We're just going to subtract the cases for the second group when the probability I'm going to use so the probability of x2 being equal to 9 plus the probability of x2 being equal to 10. Right, so this is what we're trying to subtract from 1, and that way we'll find all the cases from starting from 0 all the way to 8. Okay, so now how do we find this? And notice that I'm not touching this part yet. And you know why I'm not touching it? Because essentially notice that these two are exactly the same probabilities. Why? Because you find the same thing here as you see here, and you find the same thing here as you see here. And since both of these random variables carry the same binomial distribution parameters, these two probabilities are exactly the same. And for that reason, we can just multiply this thing by 2. And then we will have our desired result, right? Since these are the same, 2 times this one is the same as having these two added. Okay, so let's find this probability now. So we're going to get what? We're going to get 2. So the probability of x1 being equal to 9 is going to be what? Using this probability function, we're going to have n is always going to be 10 for all of these, right? So n is going to be 10. Choose 9, that's the k value. 10, choose 9. And then the probability of completing is 0.8. Raised to the kth power, right, to the 9th power, and then 0.2 raised to the first power, 10 minus 9 difference, n minus k. Okay, and then plus the probability that all 10 participants complete the study, right? So that's going to be 10 choose 10. 10 choose 10 is essentially 1, but we're going to write it anyway just for the sake of it, for the sake of math. 0.8 is raised to the 10th power now, and 0.2 is raised to the 0th power, but we can still write it just for math. Okay, so we added that. Now we have to multiply it to this part. 1 minus, and then we can copy this down, right? Basically, x2 is equal to 9 is the same thing as this part, right? So we have the same probability here. So 10 choose 9, 0.8 to the 9th power, and then 0.2 to the first power, plus, we can copy this part because they have the same probability distribution and parameters. 0.8 to the 10th, 0.2 to the 0. Okay, beautiful. So now let's see what we get. And by the way, this will help you save time if you realize that you don't have to rework this example if you know it's going to be the same thing. It's going to save you a ton of time on your exam because you will have 6 minutes per question. Okay, so 2 times. So what does this give us? If you do this right, and I would suggest using a calculator, using the NCR function. Okay, so NCR function, you're essentially having 10 choose 9 is 10, right? So that should be clear. Memorize that 10 choose 1 is the same thing as 10 choose 9, and both of them are equal to 10 if you want to avoid the calculator for the sake of saving time. Right, so that's going to be 10 times essentially 0.8 to the 9th times 0.2 plus, so these things are 1, so it's just 0.8 to the 10th. Okay, and then multiply it to 1 minus this whole thing, right? So that's going to be 1 minus 10, 0.8 to the 9th, 0.2 plus 0.8 to the 10th. Okay, so if you do this correct, you should get an answer, and remember there will be an answer choice, and you will have to round this to the nearest 1,000. Okay, so that's going to be 0.469. Okay, so I hope this was a lot of fun. Thanks for watching, and see you in the next video.